Section 2.5 deals with simplifying of fractions, and there are three objectives. And the first one is to multiply a number by 1 to find a fraction notation with a specified denominator. And then the B part is to simplify fraction notation, and then the last part is to use a test for equality to determine whether two fractions name the same number. In other words, if they're the same. So the first aspect is multiplying by 1. So here we note that 1 we can write as 1 divided by 1, or 2 divided by 2, or 3 divided by 3, or 4 divided by 4, or in general, n divided by n. So here is the other observation, the multiplicative identity for fractions. When we multiply a number by 1, we get the same number. In other words, a equals a times 1, where a is some number. And that's the same as a times n divided by n. And again, that's equal to 1, because n divided by n is equal to 1, as we just noticed up here in the beginning. Again, that does not seem like a very important observation, but as you will see, it's actually pretty important for what we want to do here next. The next few exercises deal with just this particular idea. 1/2 times 8 divided by 8, which of course would be the same as 1/2 times 1. But from what we learned about multiplication, that's equal to 1 times 8, which is 8, and 2 times 8 is 16. So that's equivalent to 8/16. Similarly, for exercise 2, we know that 3 times 10 is 30, and 5 times 10 is 50. So it's 30 divided by 50 would be the equivalent fraction. And for number 3, we know that 4 times 13 is 52. And 25 times 4 is 100. And for number 4, we know that 8 times 25, let me just write this one out just to make sure we are all on the same page, divided by 3 times 25. So 8 times 25 is 200, and 3 times 25 is 75. So that was pretty straightforward, right? The next step is to find another name for each number, but with the denominator as indicated. Use multiplying by 1. So here we have the following problem. 4/3 is equivalent to what numerator divided by 15? Well, if we don't really know by what number to multiply the denominator to get a 15, we simply divide 15 by 3, and we know it's equal to 5. So we need to multiply by 5, and to make it a 1, we multiply by 5 divided by 5. Since that's equal to 1, it does not change the fraction that we had to begin with. So then 4 times 5 divided by 3 times 5, and that's equal to 20 divided by 15. In a similar way, we do exercise number 6. Let's look at that. And so here we have 1/7 equals 1/7 times question mark. What do we multiply 7 by to get 28? Well, we divide 28 by 7. That tells us equal to 4. And to make it a 1, we divide 4 by 4, so that's equal to 1. So we have not changed the value as a fraction. And then we multiply this as 1 times 4 divided by 7 times 4. And that would be equal to 4 divided by 28. So the question mark will be replaced with a number 4. In the same way, number 7, we have 9/10 equals to 9 divided by 10. Now we need to multiply the denominator by a number, so we get 100. Well, if we don't know what that is, we can divide this 100 by this 10, and 100 divided by 10 is 10. Again, if we do it in the denominator, we need to do it in the numerator also, because now we'd simply divide 9/10 by 10 divided by 10 or by 1, so we have not changed the value of the fraction. And then 9 times 10 is 90, and 10 times 10 is 100. So this is the equivalent fraction that we're looking for, 90 divided by 100. And we can do number 8 in a similar way. But let me just input the answers here. This was 4 divided by 28. And here the answer was 90 divided by 100. So here we have 3 divided by 15 equals 3 divided by 15 times some number that we multiply 15 with to get 45. And so in case we don't remember what that is, we simply divide 45 by 15, and that's equal to 3. So 3 times 15 is 45. Again, when we have a number in the denominator, we also need to multiply by the number in the numerator, the same one. 3 divided by 3 is 1. That's why we had the previous exercises. And so the rest is pretty straightforward. 3 times 3 divided by 15 times 3. So that's equal to 3 times 3 is 9 divided by 45. So then the answer to number 8 is 9 divided by 45. For example, to simplify the fraction 2 divided by 8, we reverse the process we did just a moment ago. So in other words, we write 2 divided by 8, and we know we can factor 2 as 1 times 2. And we can factor 8 as 4 times 2. And so then we can write that as 1 divided by 4 times 2 divided by 2. Now we know that 2 divided by 2 is equal to 1. So that would be equal then to 1/4 times 1, which is equal to 1/4. This is the answer then to exercise number 9, 1/4. Similarly, we can write 24 divided by 18 by factoring 24 into 4 times 6. And we can factor 18 into 3 times 6. So therefore we can write this as 4/3 times 6 divided by 6. But we know that 6 divided by 6 is 1, so 4/3 times 1. And any number multiplied by 1 is equal to the number. So here the answer is 4/3. Here the answer was 1/4. So for number 10, the answer is 4/3. So make sure you follow each step that I showed you here. And again, the other examples are quite similar. Uh, 10 divided by 12. We can factor that into 5 times 2. And we can factor 12 as 6 times 2. That's equal to 5 divided by 6 times 2 divided by 2. and 2 divided by 2 is 1. So we have 5, 6 times 1, and that's equal to 5, 6. So the answer number 11 is 5, 6. And number 12, we do in a similar way. In number 12, we factor 15 as 3 times 5. And 80 we factor as 16 times 5. Then we have 3 divided by 16 times 5 divided by 5. And we know that 5 divided by 5 is 1, so this then becomes 3/16 times 1, which is equal to 3/16. And using prime factorization can also be helpful in simplifying fractions. Let's look at some examples. So number 13, with the prime factorization of 35, 35 divided by 40, the prime factorization of 35 is simply 5 times 7. And the denominator, 40, we have as 2 times 2 times 2 times 5. And so we can rewrite this now as 7 times 5 divided by 2 times 2 times 2 times 5, or 7 divided by 2 times 2 times 2 times 5 divided by 5, and 5 divided by 5 is 1. So then what we have now is 7 divided by 2 times 2 times 2 is 8 times 1, and that of course is equal to 7/8. So then the simplification of this fraction, number 13, is 7/8. Similarly, number 14, the prime factorization of 24, let's write down 24 divided by 21. So the prime factorization of 24 is 2 times 2 times 2 times 3. And you can use a factorization tree, prime factorization tree, and 21 is 3 times 7. So we rewrite the numerator as 2 times 2 times 2 times 3, and the denominator is 7 times 3. And then we can write the numerator as 2 times 2 times 2 divided by 7 times 3 divided by 3. And we know that that's equal to 2 times 2 times 2 is 8 divided by 7 times 1, because 3 divided by 3 is 1. So the answer then is 8/7. And that's for number 14. Let's look at number 15. So number 15, we factor 75 as 3 times 5 times 5. And we factor 30 as 2 times 3 times 5. So we have 3 times 5 times 5 divided by 3 times 5 times 2. And now we separate them into 3 divided by 3 times 5 divided by 5 times 5 divided by 2. So all the factors are still there, 3, 5, 5 in the numerator and 3, 5, 2 in the denominator. but now 3 divided by 3 is 1, and 5 divided by 5 is 1, times 5 divided by 2. Now since 1 times 1 is 1, and 1 times 5 halves is 5 halves, so the final answer is 5 halves, or 5 divided by 2. Again, make sure you understand every step that we took here to arrive at the final answer. When we do number 16, we do the prime factorization of the numerator and denominator. And so for the numerator, 75 factors into 3 times 5 times 5, and 300 factors into 2 times 2 times 3 times 5 times 5. So you can use, again, the factorization tree that we've used before for factoring larger numbers. So this we can write as 1 divided by 2 times 2 times 3 divided by 3 times 5 divided by 5 times 5 divided by 5. So here we have the 5s and the 3s. And I included a factor of 1 because we need some factor in the numerator of 1. So then the next step is to observe that 1 divided by 2 times 2 is 1/4, and 3 divided by 3 is 1, and 5 divided by 5 is 1, and 5 divided by 5 is 1, and 1 times 1 times 1 is 1, and 1/4 times 1 is 1/4. So then the answer is 1/4. And number 17 is very similar. We factor 280 divided by 960, and the prime factorization of 280. So these are the prime factorizations. 280 is 2 times 2 times 2 times 5 times 7. And the prime factorization of 960 is 2 times 2 times 2 times 2 times 2 times 2 times 3 times 5. And so we're going to rewrite this now with a 7, since there's no 7 in the denominator. 7 divided by, and there's no 3 in the numerator, so we only have 3 in the denominator. And there are 3 2's, so we have 2 times 2 times 2 times 3. So then we have 2 divided by 2 times 2 divided by 2 times 2 divided by 2 times 5 divided by 5. 5 divided by 5. So let's count all the factors. There are 1, 2, 3 2's, and 1, 5, and 1, 7. So we've got all the factors in the numerator. In the denominator, we have 1, 2, 3, 4, 5, 6. 6 factors of 2. 1 factor of 3, and 1 factor of 5. Now, this gives us 7 divided by 2 times 2 times 2 is 8 times 3 is 24. And 2 divided by 2 is 1, and 2 divided by 2 is also 1, and 2 divided by 2 is also 1, and 5 divided by 5 is also 1, and 1 times 1 times 1 times 1 is 1. So then the final answer is simply 7 divided by 24. So 7 divided by 24. So now you see the reason why we learned earlier how to compute the prime factorization of a whole number. To help us solve questions like, problems like this. And for number 18, we use the same approach. We compute the prime factorization for the numerator and the denominator. And I leave that as an exercise for you, how to do that. But you basically know how to do it. And if not, please review what we did earlier. But the prime factorization of 1332 is equal to 2 times 2 times 3 times 3 times 37. The denominator, 2880, has a factorization of 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 5. So what we can observe here is that 37 appears only in the numerator. And in the numerator, we also have 2 times 2 times, let's see, let me write it like this, 3 times 3. And so in the denominator, we have 2 times 2. That takes care of the first 2's. So that means we have 2 times 2 times 2 times 2 left, which is 16. And we have a 3 divided by 3, and we have a 5. So in other words, we have 37 divided by 16 times 5, which is 80. And then we have 2 divided by 2, which is 1. And 2 divided by 2 again, which is 1. And it's 3 divided by 3, which is 1. And another 3 divided by 3 is 1. And we know that 1 times 1 times 1 times 1 is 1. So then the final answer is 37 divided by 80. So the key to these kind of calculations is to see how many equal factors we have in the numerator and the denominator. In this example, we had 2 2's in the numerator, so we're looking for 2 2's in the denominator, which we did here. And then we had 2 3's in the numerator, and we had 2 3's in the denominator. So that makes our 1 times 1 times 1 times 1. And then the rest we simply multiply out. These 4 2's, 2 times 2 times 2 times 2 is 16. And then times the 5, which is 60 times 5 for 80. So the simplification of the fraction for number 18 is 37 divided by 80. The last exercise are the factors used to calculate FICO scores, and we're supposed to simplify each one of these factors. So 35 divided by 100, that simplifies to 7. Well, 7 divided by 20. How do we do that? Well, 35 divided by 100, we can write as 7 times 5 divided by 20 times 5. So that's 7 divided by 20 times 5 divided by 5, or 7 divided by 20 times 1, which is equal to 7 divided by 20. So here's the in-between steps. Factoring 35 as 7 times 5. In other words, looking for multiples of 5, and then 20 times 5. And the other numbers basically work the same. If we look at 30 divided by 100, 30, the amount owed divided by 100. Again, that's equal to 6 times 5 divided by 20 times 5, which would be 6 divided by 20 times 5 divided by 5, that's 6 divided by 20 times 1, or 6 divided by 20. Of course, we can write 6 divided by 20 as a multiple of 2, so it's equal to 3 times 2 divided by 10 times 2. So therefore the answer is 3/10. So here it's 3/10. And this was 7/20. An alternate way of calculating or reducing 30 divided by 100 is to say I can factor 10. If I have 30 divided by 100, I can write it as 3 times 10 divided by 10 times 10, or 3 divided by 10 times 10 divided by 10, which is 1. So it's 3 divided by 10 times 1, which is 3 divided by 10. Again, there's very often more than one way to simplify a fraction. Let's go to the length of credit history. Here we are supposed to reduce 15 divided by 100. So 15 divided by 100. We can write it as a multiple of 5, so 3 times 5 divided by 20 times 5. So that's equal to 3 divided by 20 times 5 divided by 5, which is 3 divided by 20 times 1, or simply 3 divided by 20. And then the credit mix, 10 divided by 100. Let me just explain that in a moment. So how do we reduce 10 divided by 100? This fraction here or that fraction, they happen to be the same. So 10 divided by 100, we can factor as 1 times 10 divided by 10 times 10, which is 1 divided by 10 times 10 divided by 10, or 1 divided by 10 times 1, which is equal to 1 divided by 10, or 1/10. So for both of these, it is 1/10. So now we've reduced all the fractions here. An abbreviated method of reducing fractions is, again, to calculate the prime factorization of the numerator and denominator, and then canceling common factors. But you have to be really careful how you do that. So here we can cancel the 2 against the 2, which gives us basically a 1, and the 3 against the 3, which also gives us a 1. And so that means in the numerator we have 3 times 5, and in the denominator we have 2 times 7, which is equal to 15 divided by 14. Okay. Again, you have to be careful that you can only cancel factors, in other words, when there's multiplication involved. So in the same way, we want to simplify fractions like in number 1. So we write the prime factorization for 84 divided by 90. So the prime factorization of 84 is 2 times 2 times 3 times 7, and the prime factorization of 90 is 2 times 3 times 3 times 5. So we cancel common factors. We can cancel 2 against the 2 and a 3 against the 3. So then the answer is 2 times 7 divided by 3 times 5, or 14 divided by 15. So that's equivalent to 14 divided by 15. Similarly, the prime factorization of 35 divided by 40 is equal to 5 times 7 divided by 2 times 2 times 2 times 5. So the 5's cancel, and so what's left in the numerator is the 7. In the denominator we have 2 times 2 times 2, which is equal to 8. So the answer is 7/8 for this expression. 7 divided by 8. And we can do the same, we can use the same approach for number 3. We find the prime factorization of 690 divided by 835. So here's the prime factorizations of 690, 2 times 3 times 5 times 23, and that of 835 is 5 times 167. The 5's cancel. So we have in the numerator 2 times 3 is 6 times 23 divided by 167. So that's equal to 138 divided by 167. So 138 divided by 167. So you can see that prime factorization is a pretty important method here for reducing fractions. And for number 4, the prime factorization of 42 divided by 150 is equal to 2 times 3 times 7, 2 times 3 times 7, and 150. The prime factorization is 2 times 3 times 5 times 5. So here we can cancel the 2 against the 2 and the 3 against the 3. So then we have 7 divided by 5 times 5, which is 7 divided by 25. 7 divided by 25 would be the simplified fraction, the equivalent simplified fraction. Now, there's a word of caution when it comes to this canceling. And for example, what you cannot do, I showed you what you can do, but what you cannot do is, for example, if you have an expression 2 plus 3 divided by 2, you can absolutely not cancel the 2 against the 2, because the 2 is not a factor. In fact, the 2 is an addend in the numerator, so you can never cancel terms of a sum. Or 4 plus 1 divided by, let's say, 4 plus 2, you can never cancel the 4 against the 4, because they are terms of a sum and not, as we mentioned earlier, factors of a product. So you can cancel factors, never ever cancel terms of a sum. Never. Don't do that. That's absolutely wrong. There's no way to get it right. So don't even think about it. Next is a test for equality, and we can test if two fractions are equal. And that is if their cross products are equal. For example, if we look at the expression 3 divided by 6 compared to 2 divided by 4, the cross product means we multiply 3 times 4. In other words, we multiply across, which of course is 12. And then the other way, 6 times 2 is also 12. So in this case, the cross products are the same. And because cross products are the same, we know that the two fractions are equivalent. 3 divided by 6 is equivalent to 2 divided by 4. So all the time we've used equal sign. For example, if a sentence A equals B is true, it means that A and B name the same number. If a sentence A is not equal to B is true, it means that A and B do not name the same number. So now we're going to use this equal or not equal symbol for the open square here to write a true sentence. For example, the two fractions, 2 divided by 6 and 3 divided by 9, does that get an equal symbol or not equal? Equal with a slash through. Well, again, what we do is we form the cross product. And so 2 times, so the cross product, and the first cross product is 2 times 9, and that's equal to 18. So that's from across like this. And the other cross product is 6 times 3. 6 times 3. And that's also equal to 18. And since the cross products are the same, we put an equal sign in there. Here's a guided solution. The same question comes up here. Do we put an equal or an equal with a slash or not equal to? So we form the cross product, 2 times 20. So 2 times 20, that's equal to 40. Then 3 times 14, that's the other cross product, that's equal to 42. And since 40 is not equal to 42, we get a not equal symbol in there. Since 40 is not equal to 42, 2/3 is not equal to 14 divided by 20. So it's a very simple test. Take the cross product. And this concludes section 2.5.